Just finished wiring this generator transfer panel. The way it works is this breaker here is a 60. That's the normal utility power that comes from your power pole across. So when everything operates over here, these are the circuits. This is just normal. Now when the power goes out, what you do is you'd flip this switch down and then you'd put this 30 up, and then that would be the feed from the generator. I'll open it up here in a second and explain what I got here so you can kind of see. Okay, so that's what it looks like, and I think I have everything in here correctly. The first time I know I didn't. I had to double check here. So this grounding bar over here, this has to be isolated from the neutral bar. Those can't be bonded because this is acting like a sub panel. I brought from the main panel in here, you can see there's a, I think that's an 8 wire I brought over. It's either 8 or a 6 ground wire that feeds this grounding bar. This heavy number 4 wire is the white or the neutral. And then on the bottom here there's 2 4s that come across from the main panel that feed this 60. And then on this side, that 30, which would be the generator side, is just a 10 wire. You can see it up here is the 10 wire that goes out to my outlet or receptacle for the generator in the garage, which is a pretty short run. It's less than 25 feet. And then these are some of the circuits that come out. Now the way I got it set up is that this double 15 here is our well pump, so we'll always have water. And then some of the smaller circuits, this 115 here is going to be the sump pump, and this outlet here, which also is running the wireless for the internet. And then the other side, the 15, is the furnace, so we'll always have heat. And then this 20 here is the outlets in the kitchen, one wall of outlets, and then the other one is going to be the refrigerator outlet upstairs as well. And then what I did was I wired in another outlet over here that's also live with the generator if it ever needs to be. And if I had to, I could run an extension cord to the other refrigerator that's downstairs here if there's something that's really important in there. This is the main panel. This looks like a disaster. This looks like a huge ginormous mess. But this here down here would be the, I should turn the shed back on. This here is the 60 that comes over and feeds that sub panel or the transfer panel on the utility side. And then yeah, so that explains that, I guess. Oh, and the reason I did this, originally this box came with 2 60s, and from what I've been told is that when you're feeding in with a, like the generator I'm going to have is probably going to be like a less than 7,000 watts, let's say. When you're feeding in, it's not going to push more than 30 amps because that's, the generators are designed that way. You'd have to go to like a 10,000 watt to get something with a 50 amp plug. And in order to protect the wire, you need to have a breaker that's no bigger than what you're carrying. So 10 wire, we're going 30 amps, and that's all that generator will push in is 30 amps. So I switched out this breaker, took the 60 out and put a 30 in here. So the generator side is 30, utility side is 60. Now you're probably asking, well, why wouldn't you just do a 30 on both sides? Well, my issue is I thought if for some reason all of these circuits here were to kick in at the same time, there's no way a 30 amp breaker that on the utility side here would be able to handle that on the 10 wire. So I got it protected, and then if for some reason it does pull more than 30 amps, it'll trip the breaker, or the generator should have a circuit protector on it as well. So, and if need be, if something over here is hocus pocus with the generator side, you can always click some of these off so that you can still run the generator. So that's the way it looks. Hopefully it's legitimate, or at least up to code.